Hello microservices devs. Here is a design challenge for you. Imagine you have a user registration service that helps registering an user. And you have an email notification service that helps sending welcome email after the user registration is done. So how do you think these services will communicate? Well, approach 1. The REST approach. When the user gives the registration details, the registration service captures this, persists the data, and makes a REST call to the email notification service. The email notification service then triggers the email, sends a response back to the user registration service. Now the user registration service marks the transaction as done and sends back the response to the user. Well, this is a happy scenario. But what about the email notification service is down or it is slow? Now, when the user registration service makes a call to the email notification service, as this is down, the user registration service also will go down. And that's a serious problem. Now you, the designer, joins the party. And you are like, the user registration service job is just to register the user. Why it is keep on waiting for the response from the email notification service? Well, we can treat the registration job as a separate job, and we should not say this is a registration failure if the email notification service is not sending an email or if it is down. And you even discover a bigger problem. As this is a REST call that we are making from the service A to the service B, the user registration service over here needs to know the endpoint of the email notification service in order to make a REST call. Now the user registration service is very tightly coupled with the email notification service, which is a bad design over here. Now to fix this problem, you followed a different design approach. You bring in a server like Kafka or RabbitMQ, which is a message broker. Now the user registration service is going to be a separate service whose job is to do the user registration. And once the registration completes, it's just going to fire a user registration event and put that event inside a Kafka broker. And here our email notification service keeps on checking when a new event will arrive in the Kafka server. And when the Kafka broker receives a new user registration event, the email notification service listens to that event, captures the new event data, finds the user email, and then send the user a welcome email. Isn't it beautiful? So now these two applications are not at all tightly coupled. And even if the email notification service will go down, the user registration service doesn't bother about it and it completes the user registration work and put the event inside the Kafka broker. And when our consumer services wake up, it'll pick the new event and will send the email to the respective user. And this design approach is called an event-driven design pattern. And two of our microservices right now communicating through events.